Newton's law of cooling states that the temperature of a heated object decreases exponentially over time towards the temperature of the surrounding medium, or the surrounding area. This phenomenon is modeled by the formula capital T of little t equals AE raised to the KT plus T sub s, where the purple capital T is the temperature of the object, A is the difference between the initial temperature of the object and the surrounding area, K is a constant, the continuous rate of cooling of the object, little t is the time, and T sub s is the temperature of the surrounding area. So there's a lot of notation and some of it seems to overlap. So let's go through this, but we gotta be careful so we don't confuse one number for another. So an object is heated to 100 degrees Celsius and then is allowed to cool in a room whose air temperature is 30 degrees Celsius. So we know that the temperature, or A, is the difference between the initial temperature of the object and the surrounding area. So A is 100 minus 30, the initial temperature minus the surrounding area, which is 70. So we know that, and we know that if the temperature of the object is 80 degrees Celsius after 5 minutes, when will its temperature be 50 degrees? So we're going to have to go through a few steps. Biggest thing is we got to get our constant K. So we do know that the temperature T is going to be 80, and it's 80 after 5 minutes. And again, we know the temperature of the surrounding area is 30 degrees. So knowing all of these facts, we can plug it into our formula. So we will get 80 equals 70 e to the k times 5 plus 30. And here we're going to solve for k. So we're going to take 30, subtract it over, and we're going to get 50 equals 70e to the 5k. And then from here we're going to solve for k. We're going to divide the 70 over and reduce, and we'll get 5/7 equals e to the 5k. And then we're going to get k by itself, and the only way to do that is to get it down by using logarithms. So I'm going to use ln on both sides. So ln of 5/7 equals 5 to the k, because ln e will go away. And then I'm going to divide by 5. So ln of 5/7 divided by 5 equals k. And that we're going to need a calculator for. So we're going to bring up our calculator and we're going to plug it in. So we're going to get ln of 5/7 divided by 5. And here we're going to get a decimal, and I'm going to go to 5 deep to make sure I get it accurately enough. So negative 0.06729. So now that I have my k, I can rewrite my formula from back up here a little bit differently. I still have the surrounding area being 30 and my a being 70. So my formula now, T of t, is going to equal 70e to the negative 0.06729 t plus 30. Now, it wants to know, when will the temperature be 50 degrees? Well, right here, I got my formula. All well and good. So I'm just going to replace capital T with 50 degrees and solve for little t. So I'm going to get 50 equals 70e to the negative 0.06729 t plus 30. And I'm going to subtract 30 over, and I'm going to get 20 equals 70e to the negative 0.06729 t. And now I'm going to remove the calculator so I can have that extra space. So gone. And now I'm going to divide 70 over and reduce it down. So move this over here. So I'm going to get 2/7 equals e to the negative 0.06729 t. Natural log of both sides, so ln of 2/7 equals negative 0.06729 t, and then divide both sides by negative 0.06729. And so ln of 2/7 divided by negative 0.06729 is my t. And when you put it into the calculator, you will end up getting 18.6. And everything here is dealing with minutes. So 18.6 minutes is how long it'll take to reach 50 degrees. Now, the easy one here is, what will the temperature be of the object after 20 minutes? We already know what T is. T is 20. So I'm going to do T of 20 equals 70 e to the negative 0.06729 t. Oh, sorry, that should be a 20, excuse me, plus 30. And so when we do this, we are going to, again, let our calculator do the heavy lifting. So we're going to have 70 second ln negative 0.06729 times 20 plus 30. Oh, missed a parentheses. It happens. So parentheses plus 30. And here I'm going to get 48.2. So what will the temperature be after 20 minutes? 48.2 degrees Celsius.